Good morning to lecturer. I'm the group leader of Group B, TT9L, consists of me, Fong Reswans, the group leader, Danish Menamat Shareza, Han Yong Ting, and Vishnunanda Surai. Our topic for this assignment is understanding stroke through social determinants. Okay, the problem statement for this assignment is stroke is the leading cause of disability worldwide and is third among the top cause of death as of 2024. So early detection and prevention of stroke would significantly reduce medical expenses while also improving patient outcomes. The aim of this project is to identify the primary cause of stroke and develop a predictive model that can help healthcare providers identify high-risk individuals. The objective of this assignment, this project is identify the key risk factor, evaluate social and contextual association, and also develop an early detection predictive model.
So, good day, madam. Okay, my name is Vishnu Suren. So, I'll be talking about stroke analysis, demographic, and health characteristics. So, the research question is what are the demographic and health characteristics of patients who have experienced a stroke compared to those who haven't? Okay, so to compare the health and lifestyle traits of people with and without stroke to identify key risk patterns. Okay, so data preparation we converted key columns to create categories, okay, such as gender, ever married, work type, residence type, and smoking status. Okay, another readable label for stroke status, which means zero has not experienced stroke, okay, and then one has experienced stroke. Okay, so what we analyze, we group patients by stroke status and measure the average for age, hypertension, heart disease, blood glucose level, and BMI. Okay, so the key findings and final thoughts. Okay, so the insights are age. Okay, so stroke patients were older on average, so 67 years old versus 43 years old for non-stroke individuals. Chronic conditions, okay, so hypertension and heart disease were more common among stroke patients. Okay, so blood sugar, okay, high average glucose levels were found in the stroke group. Okay, and also BMI. Okay, stroke patients were had highly, okay, slightly higher, okay, body mass index. Okay, so the visual patterns were observed. Okay, stroke were more frequent among older individuals and those with health complications. Okay, and the next one is work type and marital status. Okay, and smoking habits showed some differences but weren't the strongest indicators. Okay, so as for the conclusion, okay, stroke is more common in older adults, especially those with conditions like high blood pressure, heart disease, or high blood sugar. While lifestyle factors like smoking play a role, okay, early detection and managing health risks are key to prevention. Okay, so thank you.
Hello, madam. I'm Han Yong Ting, and I want to proceed about the short risk prediction. For the research question we do is which machine learning model, including the logistic regression, can nearest neighbor or support vector machine that provided the most accurate prediction of stroke risk based on the patient data. For the features we use, having the numerical features including age, glucose level, and BMI. For the categorical features we use, including the gender, the status that the person married or not, the resident type, the work type, the smoking status, hypertension, and also the heart disease. For the level, it's about the stroke, that the output will be either yes or no. And then for the technical use, we use the smart to adjust the balance of the class, and also we're using the grid search CV to find the best combination of hyperparameters. So for our finding, can refer to the diagram above that is showing the model result of the prediction. So we compare the three different models. For the KNN, they're having the highest accuracy but lowest recall. Means that for the for the prediction to having the output as zero, that is the false negative, the KNN having the good performance. But in the prediction of having the true positive, that the output as 1, the KN have the low performance. And then the SVM having the lowest accuracy but highest recall. Means that SVM perform good in predicting the output as 1, that is the true positive. But in predicting the output as 0, that is false negative, VM had a low performance. Lastly, we find that the logicity regression provide the most balanced performance, they having a good accuracy and also having the good recall. So we found that it will be the better models for predicting the stroke risk. So that's all for me. I pass to my teammate.
Hello, my name is Anish, and now I'll be presenting whether certain lifestyle conditions are associated with stroke. So in terms of coding, I summarized the count in tabular format for the four attributes tested before performing the chi-square test. So as you can see, residence has the highest value, and while the others has a very low value, which we will get into next. So based on the values we got, smoking has a very strong association with stroke. So in our data, individuals who currently smoke or have smoked before the past were more likely to have experienced stroke, which suggests that smoking is actually a major risk factor for stroke. Moving on to work type, it also shows a significant link, especially amongst those who work in private or slash self-employed sectors compared to those who work in government jobs or unemployed. This could reflect the differences in work stress, job security, and even healthcare access, suggesting that occupation-based health interventions may be needed to reduce stroke risk. In contrast, for residents type, we found that there is no significant association or any association really, meaning that whether the individual is living in an urban area or rural, it doesn't seem to affect the stroke risk in this dataset. So geographic location may not be a useful predictor for stroke in this particular population. And lastly, the Marshall status, it shows a very strong association with the lowest p-value out of the four. And interestingly, stroke is more common to the people who are married. However, we can't really say for sure, as it is likely that this relationship is also co-founded by age, since obviously older people are both more likely to be married and more risk of stroke. So while the association is significant, we can't say for sure that marriage causes stroke. It's probably linked through another factor like age. So in conclusion, out of all the four, only three showed significant association with stroke, but you could probably exclude the Marshall status. So based on these findings suggest that behavioral and socioeconomic factors may play a key role in the risk and should be more focused in prevention strategies. That's all for me. Thank you.
Okay, based on the data set, the top three causes of stroke is one is age, because it's accounting for 46.3% of the total feature photos based on the data set. This aligns with many clinical research that show that stroke risk doubles with each decade after the age of 55 due to vascular aging, arterial stiffness, and cumulative exposure to risk factors. The second one is average glucose level, which is contributed to 25.2% based on the model predictive power. There's also multiple studies also shown that individuals with diabetes are 1.5 to 3 times more likely to experience a stroke due to mechanisms such as endothelial dysfunction and accelerated atherosclerosis. And then the third one is body mass index, BMI, which has contributed to 23.7% to stroke risk prediction. The obesity is a well-documented modifiable risk factor that is often correlated with hypertension, diabetes, dyslipidemia, and all of others, which is increase the stroke risk. All of this contributed to the stroke risk prediction. So conclusion we can get from this project is based on the data-driven insight. Uh, from the model we built, we conclude that age, average glucose, and also body mass index is the top three causes of stroke. So these three should be prioritized in stroke prevention effort by the non-government or also the government. So that's only from us. Thank you very much.